Continuing on, now I gotta start talking about a few things. If they were to give me an x and a y, and they say, can you convert that to r and theta? Well, if you plot the point, you're in a very good shape. That's always the key. So if I take a point given x, some x, and some y, just a point x, y. If I would like to know what r is, well, keep in mind this is a right triangle, so I could say r squared equal x squared plus y squared. Very simple. And if I want to know what the angle is given the opposite and the adjacent, I'll say that tan of theta is the y over the x, and there it is. That's pretty much how you correlate r and theta from x and y, and vice versa. Given r and theta, if I decided to find x and y, well, plot the point and pretty much that's it. If I was to rotate a certain angle and move a certain r, if I am to run this down, figure out what x is and what y is, given of course that angle and that r, well, I forgot to write r, here we go. So if given r and theta, if I want to correlate those three together, an angle, the adjacent, and the hypotenuse, cosine of theta will equal the adjacent over the hypotenuse. And if you cross multiply, and I'm sure you've seen this before, and the same way or similarly, r will equal the sine, y will equal r times the sine of theta. So those are the four equations that I need to run back and forth, and that's pretty much it. That's half of the section. And if I follow on the following, well, they say this is r and theta. Find x and y given that this is r and theta. Well, I could use the formula on part A, for example. I could say, well, look, A, that's simple. X equal r times the cosine of theta. So x is, r is radical 2, the cosine of pi over 4. That would be radical 2 times, this is 1 over radical 2, or radical 2 over 2, and x would be 1. I could, at any given time, really make use of those two triangles. They're extremely useful. This is 45 degrees, and I could draw under it and use the reference angle, which means exactly the triangles I'm looking at. If this is 1, this is 2, this is radical 3, that's 60 degrees. And I could do that all the time. I could say y equal r times the sine of theta. So y is radical 2 times the sine of pi over 4. And I could look at 45 degrees, which is the sine, which is pi over 4, and say the sine is the opposite over the hypotenuse. That is 1 over radical 2, which is 1. So this point corresponds in x and y to simply the point 1, 1. I don't know why this is coming up. I need it to look nice. Here, I could use the formula, or I could say, wait a minute, that's a special case. If I, r and theta, if I rotate to pi over 2, now I'm pointing in this direction. But if I don't move at all, I am at the origin. I could figure out this point, no problem. I could figure out this point also without doing much work. That is, if I look at the unit circle, and if I rotate to 7 pi, that's 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, I am right there. I'm pointing in this direction. And since r is negative 1, I move in the opposite direction. I am at the point 1, 0. I could use the formulas, of course, that will work, but this is much easier. I could also take 7 pi and subtract 2 pi, because you could do that anytime, finding coterminal angles. And that gives you a pi, and I know exactly where pi is. Rotate to pi, there's pi. Since r is negative 1, you move in the opposite direction and you're right there. This, however, I could say, well, x equal, this is for part G, x equal r, which is negative 3 the cosine of 5 pi over 6. X equal negative 3 pi over 6 has a reference angle of 30 degrees. There's 30 degrees. And cosine is the adjacent over the hypotenuse. And I'll get to the plus or minus in a minute. Y would equal negative 3 the sine of 5 pi over 6. And y would equal negative 3 times, and the sine is the adjacent over the opposite over the adjacent 1/2. And 5 pi over 6 is in quadrant 2. And we know in quadrant 2, only the sine is positive. That makes the x and the y. X will be 3 radical 3 over 2, and y would be negative 3/2. So this is the same as you moving 3 radical 3 over 2 to the right, and negative 1.5 unit down. You'll be at the same location. If you want to graph those, you can. That helps a lot. If I rotate first, r and theta. If I don't rotate, this is a special case. If I don't rotate, I'm pointing in the positive x direction, and if r is 1, I move 1 unit. So that's the point 1, 0. That's a point identical to itself. And if I get to part D, I could say in part D, x equal r times the cosine of theta, x equal negative radical 2 times 1 over radical 2, again using the triangle. So x is negative 1, and y is negative radical 2 the cosine of pi over 4. Y would equal negative radical 2 times 1 over radical 2, and those cancel out, and y would be negative 1 as well. So the same way you could reach that point is negative 1, 1. And I could show you quickly on that one. If you were to rotate to pi over 4, there's pi over 4. Now you're pointing in this direction, but since r is negative, you move in the opposite direction. You're right there. And what this is saying, oh, I'm sorry, that's negative 1, negative 1. It says move 1 back, 1 down, you are at the same location. Alright? This problem requires a calculator. We're not there yet. And this you could do, not a problem. On number 8, I'm changing the directions to match your homework because I don't want it to suffer on the homework. So the same directions. It says let r be positive, theta be between 0 and 2 pi. Find the polar coordinates. This is x and y. The key is always for you to plot the point. Even if they didn't ask for it, that will be very wise to do. So negative 2, negative 2, I'm right there. So if I run a line straight from the x-axis, I'm trying to figure out what is this angle and what is this r. I want r and theta. Well, we always run to the x-axis, never ever the y, always the x-axis. We say that's the reference angle. This is negative 2, this is negative 2. Well, first things first, we know that r squared is, and I could just use the formula for r, that's not that big of a deal. R squared equals 4 plus 4, which is 8, and r will equal the square root of 8. It could be plus or minus, but here they want to be positive. So that's 2 radical 2. So, converting this to r and theta, we already discovered that this is going to be 2 radical 2. Now we want the angle. If I take tan of theta, right, only 4 formulas, r squared equal x squared plus y squared, tan of theta equal the y over the x. So tan of theta equal 1, and we know the reference angle for that is pi over 4. Reference angle mean we ignore the plus or minus. We always think of a positive. What that does, that gives us one of those 2 angles. And now we say, hey, now that we know about the unit circle, what is pi over 4 in the third quadrant? That would be 5 pi over 4. So we want to do this without a calculator. And I wanted to tackle one more. Again, the key, whether you're using complex numbers, vectors, or polar, they're really the same thing almost. Plot the point. I'm going to move negative radical 3, negative 1.7, 1. That's x and y. I want to figure out what is that in r and theta. How far do I have to rotate and how far do I move in that direction in this case? Well, r, I don't need the formula. R squared equal negative radical 3 squared plus a 1 squared. That is 4. So r equal plus or minus 2. They want it to be positive, so we're going to say that's 2. And reference angle. Remember, reference angle, you ignore the plus or minus. You want tan of theta equal y over x, 1 over radical 3. I didn't forget the negative. I'm not using it. And I look at this triangle right there, and I see tan of 30 equal 1 over radical 3. So the angle must be, and you could use degrees, but they're saying 2 pi, which means radians. So we know the reference angle is pi over 6. What's pi over 6 in the second quadrant? And that's this circle that we drew. We know that's 5 pi over 6. And there it is. And on number 10, we want to go the same idea, but now they want r to be negative. So plotting the point is the key. That's always the case. Whether you're doing vectors, complex numbers, or polar coordinates, you must know which quadrant you're in. So I picked 2 from number 10 and 1 from number 8. So first plot the point. This is x and y. This is really saying negative 2, 0. You're right there. How do you get there using, well, I really don't need formulas. I know I'm going to rotate because the rotation is positive to pi. I'll be pointing in that direction, but they want r to be negative. What does that mean? That means I really should be pointing in the opposite direction. Well, in the opposite direction, either I don't rotate at all. Is that allowed? That's allowed. So r and theta, if I don't rotate at all, I'm pointing in this direction. And if r is negative, I move in the opposite direction 2 units. This turns out to be identical. If I look at the point 1, 0, however, that simple point in x and y, well, we have a problem because I need r to be negative. If r is to be negative, at 0 I'm pointing in this direction, but I should be pointing in the opposite direction. So I need to rotate to pi. And once I rotate there, I am going to move in the opposite direction 1 unit. The point 1, 0 in the rectangular coordinates is the equivalent of negative 1 pi in the polar grid. And if this is x and y, we did this already. We moved 2 back, 2 down. We already figured out this is 2 radical 2. And we figured out the reference angle was pi over 4. The exception now is we want r to be negative. So r and theta, we want r to be negative 2 radical 2. Well, we have a problem because if we are pointing in this direction, we'll never be able to reach this point with r being negative. Then we should really be pointing in the opposite direction. Isn't this pi over 4? If I rotate to pi over 4, I'm already pointing in this direction. Since r is negative, I move back that many units, and guess where I am? At the location desired. And this will be your first homework assignment. Even though it's only 1 through 9, please take it seriously and make sure you get that before we get to 11.4. Otherwise, 11.4 will become extremely challenging.